Hello student, welcome back. This is the third video on chapter electricity class 10. I hope you have seen the previous two video. If you have not seen the previous two video, it will be very difficult for you in this video, okay? So please the first two video check it properly, learn it, the concept, and then only come in this video, okay? Okay, today we're going to discuss about resistors in series, resistors in parallel, because there are two types of connection about series and parallel connection, okay? Now what's given, see, when two or more resistors are connected end to end to each other, they are said to be connected in series. I hope you can see in the figure. See, I'll explain you the figure first. It said that when two or more resistors, right? It can be three resistors, four resistors, or five resistors. Okay. So this is a symbol of resistance. Okay. This is a symbol of what? Resistance. First resistors, second resistors, third resistors. So they are connected with the what? Voltmeter. This is called, what's the use of voltmeter? Voltmeter is used to measure the potential difference, right? And this is what? This is the voltage. We have learned in the previous video what's the importance of voltage. Clear? So voltage help the electron to move in a particular direction, then only current generate, right? So what's the use of ammeter? Ammeter is used to measure the current, right? K is key, or you can say switch, which can be switched on and off the current. So this is a simple and remember they are, see, these three resistors, they connect one end to another end in one line, right? One end to another end. This is called series connection. This is called what? Series connection. And see, can you see V1, V2, V3? See, V1 is potential difference for resistor 1. V2 is potential difference for resistor 2. V3 is potential difference for resistor 3. Now always remember one thing, student. In series connection, your current will be constant. Current value will be same everywhere, okay? But current will be same everywhere, but potential voltage value will be different. Voltage value will be different. They will not get the same voltage. Clear? Now see, V is equal to V1, V2, V3, right? Clear? Why we wrote like it? Because voltage value is different or not, so sum of all voltage V1, V2, V3. Now see, I'll write here. Clear? Now from Ohm's law, so from Ohm's law this will be got or not? So we wrote V is equal to V1 plus V2 plus V3. Clear? Now for V1, what we write? I R1. For V2, I R2. For V3, I R3. Why you wrote like that? Because we have learned here in this figure, see, the current value will be constant. So that's why current I all constant, not R1, R2, R3, V1, V2, V3. Why I wrote? Because they have different value, right? Different potentials, right? Now using this equation, see, if you add V in place of V, what I can write? Ri. In place of V1, what I can write? Into V1, what I can write? I R1, V2, I R2, V3, I R3. So what will be common here? I will be common. Clear? So I can be cancelled. So what you got? R1, R2, R3. This is called your effective resistance. Okay, clear? See, we got here not R is equal to R1 plus R2 plus R3. Now the equivalent resistance, this is called equivalent. The equivalent resistance is thus greater than the resistance of either resistors, right? This is called maximum effective resistance. Suppose, remember one thing, if you want to get a maximum resistance, okay, if you want to get the maximum resistance, then the connection should be series connection. What's series connection? Series connection means when different resistors connected end to end, see, one resistor connected to other end to end or not, this is called series connection. Again I repeat, what in series connection, your current value will be constant, voltage value will be different. Is it clear? Now see, series connection have some disadvantage. Remember one thing, student, at home, whatever type of connection we're using, like wiring, right, These are all our parallel connection, not series connection. Why? I'll tell you now. See, these are some disadvantages. These are some disadvantages of series connection. Okay, student, see, if any of the components fail to work, then the circuit will break and none of the component will work. What it mean? Suppose in series, suppose I connected here one bulb, clear, fine, and other one bulb also, again one bulb, clear, sorry my figure, okay, clear, again one bulb, clear. Now how many bulbs we are using? 3 bulbs, right? B1, B2, B3. Now remember one thing, this is series connection. See what happens in series connection. Suppose this bulb got damaged, example, this bulb got damaged, this bulb also will stop working. This is a problem with series connection. In series connection, if one bulb or one component fail, it will affect other component also. Are you getting my point? Suppose this bulb is damaged, right, or not working, right, so this also will affect these two bulbs also, clear. So normally at home, in our home, I think you have seen, suppose one bulb is not working, right, or something, right, so it affect other also, no, right. So again, what's given, it is not possible to connect a fan and a heater in the series because they need different value of current. Yes, as we know, the heater need a lot of current, right, but fan less current, so their requirement is different or not. So in this case we cannot do in series connection. In series connection, why? Because remember one thing, in series connection what is same? Current will be same. Current will be, suppose if you connect a fan and a heater in series, they will not work. Why? Because they need different value of current, different amount of current, right? But in series connection, same current will flow in all the component. Is it clear? So this is a problem with series connection, clear. That's why we use parallel connection in our house, clear. Okay, next will be your resistor in parallel. When two or more resistors are connected simultaneously, between 2 points to each other, then they are said to be parallel connection, clear. See with this figure, this is called parallel connection. See, one after this called, we are using 3 resistors, right? Fine. So one resistor, 2 resistor. Remember when I wrote this one, this is a symbol of resistance, okay? Clear, symbol of resistance. Now first resistor, second resistor, third resistors, they connect one after another. This is called parallel connection. Now see, I1, I2, R3. Now what happened? R1 have I value of current, I1 value, R2 have I2 current, R3 have I3 current. Now student, what you've learned in series connection, what you've learned is that same current will flow in everywhere, right? Same value of current. But in parallel connection, current value will be different. But in parallel connection, your voltage value will be same everywhere. Argument point, voltage value will be same everywhere. Now similarly, we can find out this equation. See, we already done in the previous series connection. What we wrote, remember, V is equal to V1 plus V2 plus V3, but here I is equal to Y because current value is different, right? So Ohm's law, what's the value of current? Using this equation we get value current value, not V by R1, V by R2, V by R3. Why I am writing R2, R3, R1? Because resistors are different, right? So same, if you write this one, put the value, I value is what? V by R, clear. I1 is V1 R1, V2 R2, V by R3, right? So VV can be cancelled, so you got this equation, right? Clear. So this is called your effective resistance, clear. Now student, but parallel connection also have some disadvantages. See, a lot of wires recur in the parallel connection combination, clear. We cannot increase or decrease or multiply the voltage in parallel circuit. See, in parallel circuit, okay, the voltage value is same like at our house. in our home, what's the value of minimum voltage we are getting for power station? 220 volt. You can check. Okay, we're getting 220 volt. So what's the good thing about parallel connection is that different value of current will be there, but voltage will be same. See, some advantages. Some advantages of parallel connection. Each appliance get full voltage. I'll give you a point. Each appliance, whether it's heater, your bulb, whatever, they will get full voltage. Means at home, how much voltage you are using? 220 volt. If one appliance is switched on or off, other are not affected. Obviously, suppose at home, if you switch off a fan, it will affect other fan also. No, right? But in series connection, in series connection, if you switch off one particular thing, it will affect other also. But in parallel connection, we don't face that one. In parallel connection, if you switch on or off one appliance, it will not affect other. Number third is what? Each appliance get proper current depending on its resistance. So, student, so what I've learned is that, again I repeat, in series connection, um, your current value will be same or different. Current value will be same, okay, in series. But in parallel connection, current value will be different. Clear? In series connection, your voltage value will be different, but in parallel connection, voltage value will be constant, same. So normally, what kind of connection we use at home? Your parallel connection. Clear? Fine. Now, your next will be your heating effect of electric current. Obviously, by this, I think you know that. Suppose if you switch on a fan, example, if you switch on a fan or switch on a bulb, right? After a few minutes, if you touch, it become hot or not? Yeah, that is called heating effect. What's heating effect? See, for example, if I rub my hand too like that, so obviously my hand will get heat up or not. So when a current flows, a conductor, when a current flows, a conductor heat generate in the conductor, right? When a current flows, okay, I'm sorry, it's on. When a current flows, heat generate in a conductor. This is called heating effect of current. So again, I repeat, what's heating effect? Obviously, when current flows. Clear. Now, one question, right? How this heating effect come out, right? I hope you still remember. In this figure, in the previous video we explained and we have discussed that this electron, when they get the voltage, they move in this direction or not? And in that process, what happened? This electron collide with other electron. This electron will collide the atom also, right? So they offer resistance, right? That's called resistance, right? Remember one thing: when particular thing collide with other, obviously it generate heat. It generate what? Heat. So in this process, heat also will generate. How heat generate? We can say simply that when electron collide with other electron, when electron collide with the atom, right? In that process, heat generate. In the process, what? Heat generate. Clear? So now see, they have some formulas. Heat generation, they have some formulas. Okay, we can derive this heat formula. See, I hope you know this. V by W by Q. What's that? V is what? Your voltage. W is work done, and Q is what? Your charge. Clear? Now, if you cross multiply, what will get? This you will get this equation or not? And I is equal to Q by T. What's that? This is a formula of what? Current. This is a formula of what? Current, right? So if you cross multiply, you will get this one, right? Fine. Now from Ohm's law, what do you get? V, you know this formula, right? From Ohm's law, right? Now equation 1, how you can write the equation 1? See, it is equation 1, right? V value is how much? IR. Q is what? IT, right? So I square, clear? I square RT. So this is the equation. W is what? Work. Remember one thing, your work is equal to heat or energy. Argument point. Your work is equal to heat or energy. So in place of W, so as I was saying that your W is work, right? Work done. And work done formula already I told you before. What's the formula work done? Force into displacement. Now from this equation we got I square RT. Remember one thing, work done is always equal to heat and also equal to what? Energy. So impress W, I can write H also. Clear? And this equation is called Joule law of heating. Very important, student. This equation is called I square RT is called Joule law of heating. Clear? Now this equation, see, you got H is equal to I square RT. I square RT. Now see, remember student, this equation we can write in different way also. Clear? Suppose from Ohm's law, what do you know? V R I, right? From Ohm's law. So current formula will be what? Here current formula V by R. V by R. So in place of here, see, look here. In place of I can put what value? VR, right? Fine. So V square R square RT, right? So can we cancel? Yes, no. So we'll get V square T by R. This also one equation for Joule law of heating. Clear? This equation also can be used in numericals. Fine. So what is said that, see, heat is directly proportional to current. Clear? It means say if we directly square of the current, sorry, directly proportional to square of the current. Second, say that heat is directly proportional to the resistance, and heat is directly proportional to the time for which the current flow through the resistance. Clear? So you have to know what is Joule law of heating. Clear? So this equation said about Joule law of heating and how, in what it depends, right? Heat depend on the current, heat depend on the resistance, heat depend on the temperature. Obviously, suppose if the resistance more, the heat will be less or more. If the I think in the previous video we have discussed how the resistance is more. If the electrons, okay, here, if the more electron collide with the electrons in the atoms, resistance will be more. If the electron collision is less, resistance will be less. So student, remember one thing, if resistance more, heat will be more. Remember one thing, clear? And heat is always is equal to work and energy. Clear? So this is about Joule law of heating. Remember one thing, student, you have to know these equations. Okay, it will be helpful in numericals. The next will be your practical application of heating effect of electric current. Okay, heating effect of electric current. Now first, electric bulb. I think you have seen your bulb, right? Normal bulb, right? These days you can get different type of bulb, LED bulb also there, right? But we are just discussing about electric bulb, the normal, the all type of bulb. I think you have seen the some little yellowish color, right? When it glow, right? Creep out, right? Okay. I think you've seen the bulb, right? Bulb, if like that, one type of filament is there in the bulb, right? That filament is made of one material that's called tungsten. Okay, tungsten is used as filament in bulb. The melting point of tungsten, how much? 380 degrees Celsius. That's why, student, when you see the bulb, it glow or not whenever you switch on the bulb, right? Clear? Remember one thing, that small wire, yeah, this wire in the bulb, right? It never melt because the melting point of the wire is too high, 3380 degrees Celsius. Okay. Now next is, the bulbs are usually filled with active nitrogen or argon gas to prolong the life of filament, as it prevents the evaporation of filament. Now, I think you've seen the student, that filament, the bulb filament is covered with glass, right? The bulb glass, right? Under that glass, okay, inside that glass, one gas is there. That gas is, it can be nitrogen or argon. You know why they add this gas? They add this gas so that the filament, the life of the filament, the lifespan of filament should be, if the life of the filament will be more. Otherwise, if they don't put, that glass, they will come in direct contact with the oxygen. Clear? And it will reduce direct contact with the oxygen. Okay, and it will lead to oxidation. Clear? And it will lead to, it will damage the filament. Clear? Now Most of the power consumed by the filament appear as heat. Okay, only a small part is radiated in the form of light. Now, most of the energy or most of the power in the filament consumed in the form of heat. Only few or only a small part is given out in the form of light. In the form of what? Light. So this is about electric bulb. Okay, students, it's one application. The second application is your electric fuse. Here, I hope you've seen electric fuse. If you've not seen, you can check in the your meter box. Okay, electrical meter box. Okay, and downside of the meter box, one whitish, or you can see little gray type, one switch box is there. Okay, if you take out that one, you'll get electric fuse there. Okay, electric fuse is a thin wire. So okay, suppose this one end of the electric the uh, component, one wire connected like that. Okay, one wire, thin wire connected like that. It is a safety device used in household circuit. It protects the circuit by stopping the flow of high electric current. It is always connected, always remember, it's connected always in series with the main supply from where we're getting the current. And that wire is made of what? Alloy of lead and tin. Lead and tin. Now student, why we use electric fuse? Suppose sometimes it happens, or sometimes your at home suddenly the voltage increase, sometimes the voltage decrease or not. No, suppose high power is coming. Suppose suddenly, if high power current is coming right in your house, and if you don't use the circuit, if you don't use the electric fuse at home, there's a high chance that it will burn your house. It will burn the wires, and it will lead to short circuit. Okay, clear? But if you use electric fuse, okay, if you use electric fuse, what will happen when high voltage current or high amount of current coming right in your house, right? First, it need to pass that particular current need to pass through this electric fuse. Yeah. So when high amount current voltage when a high amount of power is coming right, or current right, what will happen in that case? The fuse wire will break. The fuse wire will break the high voltage. Okay, again I repeat, if high voltage of current suddenly is coming right in your house, sometimes it happen. Okay, then the power need to pass through this wire, then only to your house, different wires at your house. Okay, so when high voltage will come right, this wire will break by its own, and it prevent your house from any kind of electrical damage. Clear? There's a electric fuse is very important. Okay, will it protect our house from different kind of accident, for electrical accident. Clear? And it's made of what? Lead and tin. Clear? Now, your last topic for this chapter is electric power. See, power is what? Simply about energy, right? We are saying, right? So what's given? If I say what's energy, energy means rate of doing work, right? Yes or no? So what's electric power? It's defined as the amount of electric energy consumed in the circuit per unit time. So electric power is nothing. The electrical energy consumed in a given time. Electrical energy consumed in a given time. Obviously, how much electrical energy we consume, we are paying the bill or not. Obviously, if you use more appliance in your house, more fan, more fridge, more AC, right? Obviously, you need to pay more bill, right, to the government, right? Yes or no? So electric power is the amount of electric energy consumed, clear, per unit time. So this is some formulas given about electric power. Okay, now, so what's the formula electric power? Work done by time. Now, so work formula, also we know that V into V is what? Your voltage. Q is what? Your charge, right? Now, in place of Q, we can write IT. From where you got this one? So I hope you know. What's the form of current? Clear? If you cross multiply, you will get this one or not? So in place of Q, we put VIT, right? So what will we get? Now, we are using this equation, okay, student? This equation here, okay? Work is what? VIT time T. So it comes, we got power formula VI. Power formula we got your voltage into current. Clear? So from Ohm's law again, also remember one story, Ohm's law is everywhere applicable, right? About electricity. Clear? Now for Ohm's law, right, what is formula? V is equal to IR, right? So same thing, use this equation here. In place of V, what do we write? IR. Clear? So you get this formula of power I. So see, all this formula is very important, okay, where I'm circling for your numericals. Power is equal to VI, voltage into current, and power is equal to I square into resistance. Clear? Similarly, here also we can put I value. What's the I value, student? Tell me. I is what? According to Ohm's law. See, what we'll get? V by R, right? Clear? So similarly, in place of I, we can write V by R not here. Clear? So it'll be V square R constant. So we'll get V square by R. It's also one formula of power. Is it clear? So how many formulas are 1, 2, 3? Yeah, many are there again. Okay, clear? So you have to know each formula. Okay, clear? Now what's the SI unit of power? The SI unit of power is, what's the SI unit of power? The SI unit of power is watt. Okay, WATT. Now what's 1 watt? See, it is said to be 1 watt if 1 ampere of current, if 1 ampere, remember what's ampere? Ampere is the unit of current, right? When if 1 ampere of current flow through the circuit having 1 volt potential difference, 1 volt what? Potential difference. Clear? So simply what's 1 watt? Your 1 watt is means when 1 volt of potential difference applied and 1 ampere current flows. Clear? So that's called what? Your 1 watt. Is it clear? Again I repeat, when 1 volt is applied and 1 ampere current produced or flow is called 1 watt. Clear? Student, and there are some other unit of power, electrical power also. See, the commercial unit means which normally we use in our meter box. Okay, like how we pay the bill in terms of kilowatt hour. Clear? In terms of what? You can check in the meter box. Okay, but don't touch. You can check in the meter box. It's written that 1 kWh kilowatt. Okay, so 1 kilowatt is how much? Joules. See, joule means what? You know the energy, right? So 1 kilowatt is a kilo, means 1000. Kilo means what? 1000. And this hour will change in second. 60 into 60. So you'll get this value, right? 3.6 joule. So 1 kilowatt is equal to 3.6 joule. So these are very important for your MCQ. Clear? Now, other practical unit for power is horsepower. Okay, don't think that horse. Okay, actually horsepower, this unit we normally use in automobiles. Automobiles means vehicles. If you want to measure the power of a vehicle, okay, clear, we say we describe in terms of horsepower. So 1 HP means horsepower is equal to how much watt? 746 watts. But some other bigger unit also there, like 1 mega is 10.6 watt, giga is 10.9. Okay, clear? Fine. So student, this we have done with this all your explanation for this chapter electricity. Okay, please, I may miss out. If there's any clarification or if you have some doubt, please contact me. Clear? I tried my best to explain simple way in simple language. Okay, clear? Please go through all the 3 video, then only go for your question answer and numericals. Clear? Fine. See, as today in this video we have learned about series connection, parallel connection. In simple, again I want to repeat once more. What's series connection? Remember one thing, series connection means when all the resistors are connected end to end, one after another, right? So what's the good thing about what's the in series connection? So also remember one thing, in series connection your current value is constant, voltage is different. Clear? Is it clear? And this is the disadvantage, right? What's the disadvantage? In series connection, already I said, right, if one bulb stop working, other bulb also will get affect. One fan stop working, other fan also will get affect, right? Clear? So this is the series connection. Your next is parallel connection. So parallel connection is see, you can see here one after another, right? In parallel connection, what is same? your voltage is same, right? Means all the appliance will get the same amount of voltage. So normally what voltage, how much voltage we use at our home? 220 volt, right? So I hope you know what's voltage, right? Voltage means which is pushing the electron, right, in one direction, right? We already done in the previous video, right? Pushing the electron in one direction, clear, so that current can produce, right? Because current, how current produce? Current produce means movement of charge, right? When the charge move, current produce. So in parallel connection, current value will be different, right? Yes or no? But voltage will be same, clear. But this is and normally we use parallel connection at home. Why? Because we need fixed voltage for all the appliances, right, to work, right? There's a 220 volt, means 220 volt is getting all by the fan, bulb, everything, right, in our house, right? Clear? Okay, for this electricity chapter we're done. Please, if you have doubt, please check the first video first, then on second, then only third, then only you understand. Okay, if you have doubt, please ask me. Okay, then thank you.